Hello, this is a lesson on identifying constant rate of change using a table. So today we will be using a few examples and a few. Hello, this is a lesson on identifying constant rate of change using a table. So today we will be using a few examples and a few key terms to remember by the end of this lesson. Part 1 of this lesson is the use of the table and how it can be used to find the constant rate of change. This is very similar to unit rates and all of those correlations as well. We're going to start with a story problem, and this is a table used as an example of how we can use the table to find the constant rate of change. So this table shows the amount of money a booster club makes washing cars for a fundraiser. We have to use this information to find the constant rate of change in dollars per car. Now the keywords there are dollars per car. So if I say to someone, we want to figure out the dollars per car. If we're writing that in labeled math form, then we know that we are going to end up dividing the dollars by the cars. And that is how we are going to find the rate of change. So another way to write this is change in dollars over change in cars. If you want to save yourself some writing, the mathematical symbol for change is a triangle. That's just a little shortcut for you though. So now we're going to look at the rate of change on each side of the table so that we can understand how we get these numbers down here. Let's start with the number first, just for fun. So we're going to start with the denominator. As you can see, the cars are labeled up here and the money is over here. If we look at the first column and we see that 5 goes to 10 and 10 goes to 15 and 15 goes to 20, we can figure out simply by going 10 minus 5 equals 5. We realize that the rate of change is a pattern of 5. Now if you go to the other side where the money is, we can do the exact same operation. 40 to 80, 80 to 120, and 120 to 180. We realize that there's a rate of change of 40. How we did that last time, we did 80 minus 40, and we got 40. Bingo. Now after this, all we have to do is plug our results into our equation. But we remember, we did the denominator first, so if starting with the numerator is easier for you, then do what's best for you. Some people like starting with the denominator. Anyway, let's plug our numbers in. So we have 40 in the numerator and 5 in the denominator. You divide these out. 40 divided by 5 equals 8. So that means that how we're going to label this is using the labels that we have up here. So that means that this is $8 per car. If you're not sure and you don't remember how to do that, you can always go back up to your first example that you made from the story problem. Pause it. 1. We're going to move on to another example of how we can find the constant rate of change using a table. this is a table that shows the number of miles a plane traveled while in flight. We're going to use the information to find the approximate constant rate of change in miles per minute. So I'm just going to write those words out to start. Miles per minute. Obviously, as we go along, we will abbreviate because that's how we label things in math. Now, if you look at the table, we can already see kind of a consistent jump. I guess I could say we can use jumps. Yeah. So when we go to our equation, we're going to start actually with the numerator this time so that you guys can see how it's done. So miles, we look in our table and we see the abbreviated form, MI for miles. So you know that you're going to be starting with distance. Now, if we're going from 290 to 580 to 580 to 870 and so on, we realize that it is multiplying itself by 2, or you could just say adding 290. So we realize that our numerator is 290. So as we go, it just gets bigger and bigger. Now, we do have a denominator. And that is the time right here. This abbreviation is minutes to minutes. And as we continue to go, we see that 30 goes to 60, 60 goes to 90, and 90 goes to 120. So on this side, we have 290. And we realize that there is an increase by 30. And how you can do that is just taking your first two steps and subtracting. And you get 30. So that right there is your denominator. 290 divided by 30. If you take your calculator, you get an approximate, as they asked for in the story problem, answer. 9.6 repeated. Now, I want to put an emphasis on the repeated part of this, because that's what this label in math means. It means that the sixes just keep going on. So if you see it in your calculator, it'll look like this. And then however many it goes, it'll have a dot, 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 because it continues on forever, as you can see. So now that we have our 9.6 repeated as our approximate constant rate of change in miles per minute, we have to remember to always label our answers. And depending on who you're answering this for, they may have you round this to 10 for a better approximation if they want a whole number. So either answer is correct, but it just depends on what the standards of your teacher is. When we label either of these, we want to do our abbreviations as we had up top. So it will be approximately 10 miles per minute. And that is the number of miles a plane traveled while in flight. And that is your answer.